All right, so we're going to continue now, getting to have vectors that are either in 2 or 3 dimensions. So they have the I, j, and k hat unit vectors attached to them, and same idea, you have to find a cross product. Now, before we start, I want to refresh your memory how you go about when you have I, j, and k, and how do you go about to find what is the cross product between the unit vectors. So here's a simple rule of remembering how this goes. You probably did this in calculus, I don't know, but I want to make sure. So say you put your I hat, j hat, and k hat. Here you go, we put the hats right there. And you go into the trig direction, so counterclockwise. So here you go, you start with the I, go down to the left, I hat, cross product with j hat. Well, you're going to run into the k hat. Essentially, what this is telling you, if you apply the right-hand rule here, it will give you the direction if it's going to be into the page, out of the page, or if it's going to be a plus or minus 1, right? Good. Now I'm at j hat. I'm going to continue with this, and you're going to get the gist of it. So j hat cross multiply with k hat. And if you look at it, if you go around, j times k, you run into the I hat. Similarly, the last one, I'm at k hat right now. Cross multiply with I hat. All right, so you're going to run into the j hat. This is probably very useful for the whole chapter if you are dealing with at least 2-dimensional, or if you have a 3-dimensional, even more so useful. Similarly, you would say if you have a unit vector I hat multiply with itself, or j hat multiply with itself, cross multiply that is. And similarly for k, either one of those gives you 0, right? The angle between them is 0. So the overlap sign of 0 is 0, so they cancel out. Okay, so let's move on to our vectors. So we're going to have here A cross product with B. We're going to copy them first. 3I hat plus j hat. Make sure you remember this is a cross multiplication where all the rules between the unit vectors, you will have to comply with those. Now what do we have here? Come on. I don't understand why it's not writing. All right, here you go. 3I hat minus 2j hat plus 2k hat. Very good. So it kind of works the same way like you learned from algebra, right? So you have a distributive property here. It's nothing else but doing FOIL or walking across and taking each one of the terms and walking it to the parentheses, but make sure you respect the rule of the cross products for the unit vectors. So let's see what we get. So this becomes 9. And now you simply have to look. It's going to become I hat cross product with I hat. So you're going to continue minus 6. And then you have I hat cross product with j hat. Now I'm going to continue plus 6. Again, I hat cross product with k hat. Okay, I'm done with the first part. I'm going to continue no more plus. All right, so we're going to have 3 j hat, and remember you have to put them in that order, okay? Because by the way, if you move in the opposite direction here, then everything here will become negative, okay? Okay, so now where was I? 3 I hat j hat times I hat, okay, minus 2 j hat j hat. And finally, plus 2 j hat k hat. Good. So now let's kind of analyze each one of those terms. So remember what I said, this part right here, this is a 0, so this term will go away. I'm going to check if there's any other one that repeats. Okay, this one is 0, so this term will be a 0, goes away. And now we're going to focus on what do we get for each one of them. So if you look, I hat times j hat, this part right here gives you a k hat. I hat times k hat, it's kind of like going the opposite direction here. So that will actually become negative j hat. j hat times I hat. Again, this is going in the reverse order, meaning that this part right here will be a negative again. That's a negative k hat. And finally, j hat times k hat, that is an I hat. Good. So let's summarize what is left over, actually. So we're going to end up with, and then in the end, we're going to put them in order, right? So we're going to have minus 6 k hat, minus 6 j hat, minus 3 k hat, and plus 2 I hat. All right, so now we're going to list them in order, I, j, k. So we get 2 I hat. All right. J, we only have one term, so minus 6 j hat. And then if you look, you have a negative, and this becomes a negative 9 k hat. So here it is. This is the answer for evaluating the cross product of such vectors. You know, I'm going to probably continue to the next application, which kind of applies the same rules here. So we want to keep that fresh in our mind. So let me move this up a little bit. Okay. Now here, this is a little bit different of what you are having or dealing with. We're getting to a little bit more into physics right here. So you have a force that is actually acting in a j direction. Okay, so that's going to be in a y direction. It's exerted on a particle, and this is the position or the distance from the center of mass. And now they ask you, what is the torque on the particle about the origin? Since you have the position from the origin given by r, you have the force. They are both vectors, so you know what the torque is. So tau, which is your torque, as a vector, is the cross product between r and f. So now we're going to actually depict them. It's kind of like taking the application from above and putting it a little bit more into physics, I would say. Good, so let's copy what we have here. So you have 5 I hat plus 5 j hat. Remember, you're going to do, let me change that, you're going to do cross product. And you're going to multiply that with negative 10, and that's j hat. Don't forget to put your units. So force is measured in Newton, the distance is in meter, so as you already know, torque is Newton meter. Okay, so now it's the same idea. You're going to apply what you just learned above, and I'm going to let you depict this. Maybe stop the video and try to do it yourself, and then compare notes of what I'm getting here with what you're getting. Yeah, so what do we get here? So we get negative 50, and then you get I cross product with j hat, and then minus another 50, and this time you get j hat cross product with j hat. And again, these are Newton meter. Remember what we talked above. So this part right here is 0, so this term does not exist anymore. Final answer for your torque. As a vector or in a vector note, it's negative 50. And if you look above, I times j, look at the direction, I times j is going counterclockwise, there will be a positive k. So there will be a k hat. And these are Newton meters. All right. So this is the direct application of your cross product. Okay then.